Hello guys, how are you all doing today? And it's Jalajora here again, back with another video from BHM at GCSE Chem. I don't know why I can't say my name properly these days, and it's Jalaj Aurora here again, back with another video from BHM at GCSE Chem. So yeah, that's better. And I haven't been able to put the kind of the remaining links of the sections of chapter 2 on my website yet. I'm really sorry again. After this I'll try and do them, and I'll put C3.1 on there as well, which is states of matter, the start of the chapter 3. So the first one we're doing, the first part of the chapter 3, we're on chapter 3 today, and it's all about C3.1 is all about states of matter. Yeah, and the whole of chapter 3 is just called structure and bonding. And by the way, the book I'm using is this one. So it's the GCSE Chemistry Revision Guide from AQA and from Caboodle. Basically the AQA GCSE Chemistry Caboodle Revision Guide. Just going back to the chapter 3. And so today's all about C3.1, which is states of matter. So we're starting chapter 3. And chapter 3, I believe, has 12 sections. So it is quite a big chapter. And I believe it's actually the biggest chapter in the book, and the entire, the biggest chapter of all of them, isn't it? I'm pretty sure. Yeah, there are 12 sections, 2 of them being for triple science students. The last one's C3.11 and C3.12. But I'll get to that, when we get there. So today, as I said, C3.1, all about states of matter. And if you're following using the student book, it's pages 36 to 37 that you want to be seeing. So let's start. So the 3 states of matter are solids, liquids, and gases. Yeah, so we know that 3 states of matter are solids, liquids, and gases. And now all matter is made up of particles. So you could say all matter is made up of particles. These are just little details that you need to know. That 3 states of matter, the 3 states of matter are solids, liquids, and gases. And all matter is made up of particles. Now the particle theory describes the movement and arrangement of the particles. Yeah, so the particle theory is all about how the particles move around, and how they arranged, and they're arranged and differently in solids, liquids, and gases, and we're going to look at that later in the section, basically later in this video. And so the particles are represented by small solid spheres. So these are just 4 things you need to know, that the 3 states of matter are solids, liquids, and gases. The particle, and that all matter is made up of particles. So everything is made up of particles. Like we say, everything is made up of atoms. We say everything is made up of particles. And to be more specific, we say all matter is made up of particles, just to be a bit more scientific. And then so we also know that the particle theory basically describes the random arrangement and random arrangement and the kind of movement. So the movement and the arrangement of the particles, and we also know that particles are represented by small solid spheres. So we just represent them as small solid spheres. And basically, so here's a question number 1. Name the 3 states of matter. So that's solids, liquids, and gases. Yeah, I'll check that, by the way, but I'm pretty sure it is solids, liquids, and gases. I just want to make sure I'm not being weird. No, I don't need to check. That is pretty easy, isn't it? Solids, liquids, and gases. Yeah, I said I'd check each question, so why not? Now, how are particles represented? We just saw that particles are represented by small solid spheres. So that's the answer to the second question. So the second question was, how are particles represented? We just went through that. They're represented by small solid spheres. Yeah, so that should be right as well. I just want to go through each and every question. I want to go through the answer as well, just to make sure I'm not wrong and I haven't missed anything. So the particles are represented by small solid spheres. Good. So that's right. And then now we're moving on to the fact that particles in solids, so now we're describing all 3 states. So particles in solids are packed closely together in fixed arrangement. They vibrate constantly, because particles in a solid basically, they're packed together. They're tightly held together basically, and they can only vibrate around the they vibrate consistently around the spot, on the spot. And by the way, this chapter, this section, solids, liquids, and gases, the 3 states of matter. Basically, that is also in GCSE physics. So there's quite crossover between chemistry and physics there. But so that it comes up in physics as well. GCSE physics. So we know that particles in solid, they're packed closely together or tightly together and with a fixed arrangement, and they vibrate constantly. Particles in a liquid are close together in a changing random arrangement. They can move around. So basically, particles in a liquid, they're close together, but they're not like in a solid. They're not tightly packed. They can still move around a bit. They still have a slightly random arrangement. They still have random arrangement, allowing them to move around a bit, but obviously not as much as gases. They can't move around as much as gases, which we'll obviously look at soon. But yeah, they can move around more than solids, which can only vibrate on the spot. Particles in a gas are much further apart in random arrangement. They move very quickly. So again, particles in the gas, however, their particles move even. Gas particles, they move much faster. They have much more random arrangements than liquids and solids, and so they can move around very quickly. Now, a solid turns into a liquid at its melting point. As temperature increases, the particles in a solid vibrate faster. At melting point, enough energy is transferred for the solid to the solid for the forces between the particles to break. The particles break away from their fixed positions and start to move around. A liquid is formed. So I think for this kind of thing, it's better to actually refer to the student book where they've actually show a graph. I think it's on page 37 with how a solid changes to a liquid, then how a liquid changes to a gas. I'm not going to go through that, but basically I'll explain it here. So obviously solid turns into a liquid at its melting point. We know if we melt a solid, it turns into a liquid. So as temperature increases, the particles in the solid vibrate faster. That's what happens. So basically, when the solid reaches its melting point, what happens? There's a lot of energy, transferred. So that this to the particles, and the particles can then break. Basically, we can break the particles. Not break the particles. The forces between the particles can break. We can't break particles, but the forces between the particles can break. And this means that the particles break away from the very solid structure, and they turn into a liquid, and so the particles can move around. And I think this action just shows particles moving around, helps you remember, I think. And then a liquid is formed. So hopefully that makes sense. A liquid then turns into a gas at its boiling point. So a very similar thing happens from a liquid turning into a gas. Just that the only thing is that when you're boiling something, when you're turning a liquid into a gas, you're boiling the liquid to turn into gas. But when you're going from a solid to a liquid, you're actually melting the solid to get into the liquid form, basically get into the liquid form. So again, as the temperature increases, the particles in the liquid move faster. So your liquid turns into a gas at the boiling point. At its boiling point, so as the temperature increases, the particles in the liquid move around faster. And then as more energy is transferred, to the substance, some of its particles can escape from the surface of the liquid. Like when we for example heat liquid water, some of the particles can actually escape from the liquid, and they can escape from the liquid and escape from the surface of the liquid, and then these can basically before the boiling point's reached. We say that the liquid is evaporating now because these particles are escaping the liquid surface. These are evaporating. And I think this action is good, just showing that they're going in the air, they're evaporating. At the boiling point, the bubbles of gas are formed within the liquid and rise freely from the surface, and then a gas is formed. So hopefully that makes sense as well. Again, to actually understand it properly, I would go through the student book, which is the big book, pages 36 to 37. I think they have a really good graph on 37 actually, which really helps. But, it's pretty logical, this, so hopefully that makes sense. Now, substances with higher melting and boiling points have stronger forces between their particles. Obviously, because if you have a higher melting and boiling points, it means that it takes more energy to break these stronger forces of attraction, resulting in higher melting and boiling points. And this stuff, about melting and boiling points really, it builds up massively in A-level chemistry. So it's really, really important to actually understand this right from GCSE, especially if you're going to take A-level chemistry. This stuff just builds on in A-level chemistry. Like when we talk about, the three different types of intermolecular forces, but I'm not going to go into that obviously because that's not GCSE, but basically I'm just trying to say this stuff's really important for your exams in GCSE, and if you're doing A-level chemistry, it's also really, really important because this stuff just extends at A-level, these ideas, basically. Then what we have, wait, let me just clear this, sorry, something on my computer, 1 minute. Sorry about that, guys. So substances with higher melting and boiling points have stronger forces of attraction between their particles, or stronger forces of attraction between the stronger forces between the particles. So hopefully that makes sense. More energy will be required to break those forces, meaning higher melting points. Obviously that makes sense. Each change of state is reversible, because obviously this is a physical change, not a chemical reaction. It's a physical change. So therefore these are these changes are reversible. Like for example, when you have ice, you can melt it to water, liquid water, but then you can actually also freeze it back into ice. So that's a physical change. You can get the ice back from water, if hopefully you get what I mean there. Gases condense to form liquids, and liquids freeze to form solids. Yeah, that's what I was saying. So gases can actually condense to form liquids, and then liquids can actually freeze, or you can even say solidify to form solids. So basically, you just want to go through that actually. When you're going from solids to liquids, you melt. When you're going from liquids to gases, you boil. Or solid to liquid, you melt. Liquid to gas, you boil or evaporate. Not evaporate, vaporize, I think that's the word, yeah. And then if you go from gas to liquid, you condense, and then from liquid to solid, you freeze or solidify. And then also another thing, which I think is more related to GCSE physics, but it's good to know for GCSE chemistry as well. If you're going straight from a solid to a gas, that's called sublimation. That process is called sublimation. So it doesn't go through the liquid state, it just goes from a solid to a gas, straight to a gas. So yeah, hopefully that makes sense. And so now question number 3 here. Which states contain particles in a random arrangement? Well, that's liquids and gases, because obviously solids have a very fixed arrangement, but liquids, even though their particles aren't that far apart, they still can move around. They have a random arrangement, and so do gases. Obviously we know about gases. They definitely can move around like very, very fast. So hopefully the answer should be liquids and gases. And then here's another question 4. Why do substances have different melting points? Well, that's because the substances have different strengths of intermolecular forces there. That's basically the answer there. So hopefully that should be right as well. So yeah, have different strengths of forces between their particles. Yeah, the reason why is because substances have different strengths of forces between their particles. Some could have very, very strong forces, some could have very, very weak forces. So that's basically the reason there. And then now we're going on to something that's for higher tier students only, and that's that the particle limitations of the particle model. Now the particle model does have its limitations, and these limitations are that the particle model is limited because it assumes that particles are solid spheres with no forces between them. We don't assume any forces between the particles. However, so basically the problem with the particle model, it's limited because it assumes particles are solid spheres with no forces between them. So you just need to remember this part really. It's just regurgitation. Yeah, this part is just to regurgitate. Yeah, just remember it. However, particles can be atoms, molecules, or ions. The particles could be atoms, molecules, or ions. They can vary in size. They could contain many atoms, and they are not solid or spherical. So we draw them as spherical or solid, and solid as well, but they're not actually solid or spherical. They can contain many atoms, and obviously there's also there can be atoms, molecules, or ions. And they can vary in size. So obviously if I don't remember this at the moment, because I've done my GCSE already, got that grade 9, so I don't really need to remember this stuff, and it doesn't really come up in A-level chemistry, but you guys doing your GCSEs, I'm not going to put much emphasis on this because it's literally just learning these limitations and learning the limitations that the particles we draw as solid spheres with no forces between them, and what particles actually are, how they're represented, and stuff like that. So hopefully that makes sense. And study tip here is close the book, draw label diagrams to show the arrangement and movement of particles in solids, liquids and gases. Now that would really help. If you could draw those three structures, you'll be laughing in the exam if the question comes up. Also, forgot to show you this kind of diagram over here, which just shows that this is your, this shows your solids, this shows your liquids, this shows your gases. Basically solid, liquid, gas. So that's how you draw them, basically. Hopefully that makes sense. And I'll also read out what it says here. That it says that, in solids, again, obviously the particles are tightly held together and the particles vibrate. And in liquids, particles slip and slide over each other. We know that they can move about a bit. And then particles in a gas obviously move very quickly in all directions as the particles bash against the walls of the container, and they exert a force that causes pressure. Yeah, they can exert a force on the wall which can cause pressure. Again, this is very interlinked with GCSE physics concept of force and pressure. So yeah, I think it's really helping both your your chemistry and your physics at the same time, which is great. I love things that are cross curricular, because that's why I've taken A levels in maths, chemistry and physics, and things are so interlinked within all three subjects. So that's really good, because it helps me out basically. So that's I like that part when there's a topic in one subject and also in another subject. So just to finish off, we'll just look at the key points. And by the way, these limitations of the particle model, I don't know if I mentioned before, but these are only for higher tier students. Also the keywords, the key word for today, for this section, I don't know if I mentioned it, is particle theory. That's the only key word. Now let's go through the key points just to finish off. So the three states of matter are solids, liquids and gases. Yep. The particle theory is used to explain the properties of solids, liquids and gases. We can use the particle theory, yeah, we know that. Now in melting and boiling, energy is transferred to the substance from the surroundings. In freezing and condensing, energy is transferred from the substance to the surroundings. So in melting and boiling, energy is transferred to the substance from the surroundings. Energy is transferred. Okay, wait, let me just go through this one. Wait, on myself. In melting and boiling, energy is transferred to the substance from the surroundings. Oh yeah, because you're heating it. Remember, because when you're melting when you're melting or boiling, you're heating the system. So therefore, energy is transferred from the substance to the energy is transferred from the surroundings to the substance, or energy is transferred to the substance from the surroundings. You can say, sorry, this wasn't mentioned in the in what we read before, but hopefully you understand that. Because obviously you're heating the system up, you're heating the substance up, so obviously energy will be transferred to the substance from the surroundings. However, when you freeze and condense, so in freezing and condensing, energy is transferred from the surroundings, so from the substance to the surroundings, because now you're taking heat out, you're making it cooler when you're freezing and condensing. That's where energy will be transferred from the substance to the surroundings. So let me just make that clear again. When you're melting and boiling, energy is transferred from the to the substance from the surroundings, and then when you're freezing or condensing your energy is transferred from the substance to the surroundings. So yeah, so melting and boiling, it's surroundings to substance, and then freezing and condensing, it's substance to surroundings. Hopefully that makes sense. And then the last thing is that for higher tier students, it says H here, for higher tier, the simple particle model of solids, liquids and gases is useful, but it has limitations. Well, it has its limitations because the atoms, molecules and ions that make up a substance are not solid spheres with no forces between them. So they aren't solid spheres basically as we draw them. It's not like that, and it's wrong to say the other limitations. We say that there are no forces between the particles, but obviously there are forces between the particles that obviously determine, and the strength of those forces obviously determine the melting and the boiling point. So as previously mentioned in this section. in this video. So guys, that's it for section C3.1, the states of matter. Let me just say, what is it called? Yeah, it is states of matter. And tomorrow we'll be going to C3.2, which is about atoms into ions. So that's going to be interesting. Yeah, I hope you found this video helpful. Make sure to share, like, and subscribe. Turn the notification bell on if you haven't already, so you're notified and updated, obviously, when I upload new videos that you can watch. Also, yeah, I'll try and put all the links to my websites and get it fully up to date by today. I'm really sorry for this delay. You know that I've just been so busy this week, but yeah, I'll definitely try and do it by today, and hopefully I can upload this video before midnight. I'll really try my best. It should be, you know, we still have over 30 minutes, so hopefully it should be done. And yeah, see you in the next video. Thank you very much, guys.